All right. Because we've already started Lewis structures, right? Let's see if we can get to, oops, there we go. Because we already started Lewis structures and we've already laid out the rules for them, all we have to do at this point is practice, right, before we come to something new and different and exciting. So what you'll notice in the packet is the compounds and substances that we have to draw structures for are all polyatomic. They have many atoms. And we need to figure out how to handle that. Further, some of them have charges, and we need to figure out how to handle that. So we're going to look at some here as examples, and that should help you go forward with drawing Lewis structures and get a little bit better at it, hopefully. So let's look at one. We'll start with CH2S, okay? CH2S. And the very first thing that we have to do, we've already set up this as a system, the very first thing we're going to do is count valence electrons, right? So we're going to count valence electrons, right? Well, carbon, we know, has 4 electrons, right? Carbon has 4 electrons. Hydrogen has 1 electron, right? But we've got to multiply it by 2 because we have 2 of them. So that's 2 electrons, okay? And sulfur has 6 electrons. And you might say, how do we know all that? Well, I know all that because I happen to be sitting right next to a periodic table. And so carbon, 1, 2, 3, 4. Hydrogen just has 1. And sulfur has 1, 2, 3, 4, 5, 6. So we can count the valence electrons. Remember, we always count from left to the element we're describing, but we skip the D block. All right, so there we are. So we have this. Well, if we add them up, we get 4 plus 2 plus 6 is equal to 12, it looks like, electrons, okay? So 12 electrons is what we have to play with, okay? But the question is now, how do we lay them out? How do we lay them out? Well, we're going to put one atom in the center, okay? We're going to put one of these atoms in the center, and we'll lay the other ones around it. And the reason is because if you look at this, carbon, for example, has 4 electrons, right, to start with. But that means another way of looking at it, right, it's a little bit like being an optimist or a pessimist. Carbon has 4 electrons, yay, but it needs 4 electrons, boo, right? And so if it needs 4 electrons, right, the glass is half empty, right? Carbon has 4 electrons, but it needs 4 electrons, and so it's going to have to, right, it's going to have to share 4 electrons, right, because it needs to share with 4 other things to gain those 4 electrons. It's going to share 4 electrons, or another way of saying it is it has to form 4 bonds, okay? So carbon generally forms 4 bonds unless there's a charge to allow it to gain those extra 4 electrons. Sulfur, we can do that same sort of analysis for. Sulfur has 6 electrons, so therefore it only needs 2 electrons. And therefore, it only has to form 2 bonds, okay? So if we look at this, we're going to put carbon in the middle because carbon needs the most bonds, okay? So let's try this. We'll put carbon in the middle. We'll put sulfur around it. And we'll put hydrogen around it. And we'll put hydrogen around it. And here's our skeleton, okay? Well, if I've drawn my skeleton, I need to then fill in octets. So this has 2 on the bottom. I'll put 2 on the left, 2 on the top, 2 on the right. This has 2 on the left, 2 on the right. Carbon, I should say, has 2 on the left, 2 on the top, 2 on the right. And so we'll put 2 on the bottom. So octet around carbon, octet around sulfur. Remember, hydrogen only gets 2 because it's in the first energy level, and it can only hold a total of 2 electrons. So 1 bond, and it is done. So this looks great. Let's count the number of valence electrons we've used. So 2, 4, 6, 8, 10, 12, 14. This is 14 electrons. Well, if it's 14 electrons, and we only have 12 electrons, then we have 2 electrons too many. right? We've used too many electrons. Well, we know that when we have too many electrons, we're going to add a bond, right? In fact, for 2 electrons, we only have to add 1 bond. So, add 1 bond, right? For every 2 electrons too many, we just add an extra bond. Well, we can't add a bond between hydrogen and carbon because hydrogen only gets 1 bond. So we have to add it between carbon and sulfur. And so what we're going to do is draw C, S, H, H, dot, 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 and we're done. And the reason I know that we're done is because I used to have 14 electrons in the structure. I added an extra bond, but I took 2 off of the sulfur and 2 off of the carbon, right? So I added 2, but I took away 4. And so now I'm pretty sure I'm going to be down to the right number of electrons. And in fact, 2, 4, 6, 8, 10, 12, 12 electrons, okay? So I do my checklist, right? We have full octets. Check, we have the right number of electrons. Check, and so we are happy and we are done, okay? All right, so this structure is done properly. Now, you might, when you're doing this, say, hey, why do I have to have a central atom at all? Well, let's look at that. Let's suppose I instead laid it out like this, H, C, S, H, okay? H, C, S, H. This seems reasonable, okay? This seems reasonable, right? Hydrogen only has 1 bond, and I can fill in my octets, right? Okay. Well, how many electrons have I used? 2, 4, 6, 8, 10, 12, 14. 14 electrons. Again, I can do my same analysis, 12 electrons, 2 electrons too many. Right, too many. And so what I'm going to do is add a bond. Well, I have to add it again between the carbon and the sulfur. And so what's going to happen is I'll get H, C, double bond, S dash H, right? I add, let's see, 2, 4, 6 on the carbon, so I need 2 more dots. 2, 4, 6 on the sulfur, so I need 2 more dots. And this would also make me happy, except here's the thing. How many bonds does carbon end up with, right? So this looks like carbon has 3 bonds, right? Well, we know that carbon usually wants to form 4 bonds so that it can have 4 of its own electrons and 4 shared from other atoms, right? Sulfur typically only needs to form 2 bonds, right? So that it can have its 6 electrons plus 2 from other atoms. What this means is that at this point, sulfur has effectively shared more electrons than it cares to share. In other words, giving up an extra one of its original electrons, and carbon hasn't shared as many as it ordinarily shares. So this is actually a worse structure, right? We would prefer, right, so this is also 3 bonds, right? This is 1 bond too many. 1 bond too many. This is 1 bond too few. And so it ends up, we're going to choose this structure preferentially because this structure not only fits these 2 criteria, but it also gives carbon 4 bonds and sulfur 2 bonds, which is going to be a lower energy system. Next week, we're going to talk about something called formal charge, where I can actually demonstrate why carbon carbon having 3 bonds and sulfur having 3 bonds is a higher energy state. But at this point, we should be a little gun shy of this structure because this has too few bonds on carbon and too many bonds on sulfur. And that works very well to analyze this system, okay? So this is the better structure, okay? Well, let's try a new one. Let's try, in fact, PO3 3-, okay? The thing I want to focus on here is how to count valence electrons, okay? This is an ion, and so we know that phosphorus has 5 electrons, 5 valence electrons, right? 1, 2, 3, 4, 5, right? 5. We know that oxygen has 6 electrons, okay? But we've got 3 of them, so we have to multiply it times 3, which is going to give us 18 electrons, okay? We know that we have a -3 charge. And if we have a -3 charge on this overall species, that means we added 3 electrons. Another way of saying it has a -3 charge is that means we have an extra 3 electrons. These mean the same thing, right? And so that's 3 electrons, okay? Well, if we look at that, 5, 18, and 3, 5 plus 18 is 23, plus 3 is 26, for a total of 26 electrons, okay? Okay, so the first thing we need to stress is counting electrons in an ion. Then we're going to lay out phosphorus. Let's see, if it's 5 electrons, that means it needs 3 bonds, right? If oxygen has 6 electrons, we would assume 2 bonds. So, looks like phosphorus goes in the middle. We put our oxygens around the outside, right? And then we lay out our octets. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right, and there are our full octets. Again, I want to stress, if you lay things out along straight lines, right, so that everything's at right angles, it's much easier to count octets because you can look at them as being top, bottom, left, right. You can just see, you can sort of visualize the sort of box that's around oxygen, and you know that you need 2 electrons on each side of your box to have for a full octet. And that's a quick way of counting. It's much easier to count at right angles. Anyway, so we count this up: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this has 26 electrons. And so this looks great. We have the right number of electrons. We have full octets. And so we are done. Full octets, right number of electrons. Check, check. So yay. All we have to do is draw this properly. And you might say, oh, but I thought we did. But you were not remembering that it's an ion. And so the way I would draw this is this way. I would draw my structure with my dots. Yay. Right? And I would then put it in brackets and put a 3- charge on it, right? Because it's an ion, it needs to be in brackets with its charge, okay? All right, well, let's try one more and see what we can do with this. Let's do N3-. N, but this time we're going to do N3 with a -1 charge. N3-. Okay? And let's see if this makes any sense. Possibly it does. N3-. So this seems easy to count, right? Easy to count. We have N, which has 5 electrons, okay? But we have 3 of them. And so that's 15 electrons. We have a -1 charge. And so that's 1 extra electron for a total of 16 electrons. Okay, 16 electrons. Well, let's see. What atom do we put in the center? Do we put N, N, or N? I think I'll put N in the center. And I'll put my skeleton around the outside. Right, N, N, N. And we will fill in our octets. And there we go, full octets. How many electrons have we used? Well, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's 20 electrons. Okay, 20 electrons. Well, we only have 16 electrons. Right, that's 4 electrons too many. That's cuckoo bananas. Right? And so that means we have to add 2 extra bonds. right? Because for every 2 electrons too many, we need to add an extra bond. Well, let's do that. So we have N. Let's put 1 this way and 1 this way. Make it symmetric. And let's see, let's fill in our octets. 2, 4, 6, 8. This guy is full. 2, 4, 6, 8. 2, 4, 6, 8. Right? And so this is the right number. This is full octets. I like that. Right? It has 2, 4, 6, 8, 10, 12, 14, 16 electrons. Right? So it's the right number of electrons. So that's good. It is, however, an ion, so I'm going to put it in brackets, and I'll put a -1 charge. Right? And there it is. So there's our structure. Okay? And that works pretty well. Okay? So when you're drawing these structures, really counting the electrons, drawing your skeleton in such a way that you can count the total electrons quickly and accurately, and then figuring out how many extra bonds you need to add, right? Once you do that, you add those extra bonds, fill in your octets, and you're done. All right? Hopefully, that is of some help. All right, and that should get you squared away until next week. Thanks so much.